Hi, I'm Dept. I'm in my final year of electrical engineering. This class is a great opportunity to learn new things and learn valuable knowledge. I loved how the class outline was set as it gave us many opportunities to learn new things and kept us on track.
Hey, I'm Zainab and I'm in my fourth year of computer engineering. In EECS4641, I enjoyed the labs immensely as they gave us hands-on experience using electrodes to record electrophysiological signals and gave us insight into how medical devices actually work.
Hi, my name is Priya and I'm in my final year of computer engineering. In this class, I was able to learn different techniques of circuit analysis. I found it interesting to know that we can adjust the values of capacitors, resistors to make the circuit behave in a certain manner.
The objective of our project is to use the EMG signal in order to detect various hand gestures. I will first give you a brief background on the biology behind the project before we describe our methodology. Electromyography is a technique for evaluating and recording the electrical activity produced by the skeletal muscles. We will be using double-channel surface electrodes to record the EMG signal. Up and down or side-to-side movements of the hand and wrist joint are mainly performed by action in the two carpi ulnaris muscles of the forearm. We will be using channel 1 to record the EMG signal for the flexor carpi ulnaris muscle. The flexor carpi ulnaris muscle is a muscle in the forearm that is responsible for flexing and adducting the hand. We will place two recording electrodes on the muscle and the reference electrode on the bone at the wrist. We will be using channel 2 to record the EMG signal for the extensor carpi ulnaris muscle. The extensor carpi ulnaris muscle is a muscle in the forearm that is responsible for extending and adducting the hand. We will place our two recording electrodes on the muscle and the reference electrode on the bone at the wrist.
We began by recording a large set of data on BioPack to use as our library of signals, which we then analyzed to determine which gestures were repeatable, consistent, and distinguishable. We decided to use the following four gestures, which each use a unique combination of the two muscles. 1. Flexion, which is a downward movement of the hand and uses the flexor carpi ulnaris muscle. 2. Extension, which is an upward movement of the hand and uses the extensor carpi ulnaris muscle. 3. A fist or a clench, which uses both muscles. 4. A flat or straight hand, which uses neither of the muscles. Once we had determined the electrode placement and gestures, we designed the circuit for double-channel recording. Our circuit consists of an instrumentation amplifier and a positive gain block to amplify the recorded signals since they were all less than 1 millivolt. Since the dominant frequencies of EMG exist below 500 Hz, we included a low-pass filter to remove all frequencies above 500 Hz and a high-pass filter to get rid of the DC component. We also added a notch filter at 60 Hz to avoid distortion due to the noise from the power source.
We created a MATLAB program to process the recorded signals. We acquired the signals at a sampling rate of 1,000 samples per second. After filtering the signals, we amplified the signals with a gain of 10. We squared the signals, which not only rectified the data, but also resulted in large amplitudes increasing and smaller amplitudes decreasing, which helped us when classifying the signals. We extracted the statistical features from our library of signals, such as the mean and RMS values for each gesture. Using the results, we were able to classify which gesture was performed. This is a demonstration of how our system works. We are using an Arduino Samurai to send the data from the circuit through the communication port on the laptop to MATLAB. We can accurately detect gestures in real time with a slight delay as we are taking the moving average over 2,000 data points. Our project is a success.
So from this project, I was able to learn many techniques such as designing a circuit that is specific to a type of signal, such as EMG. Furthermore, I found it very interesting that the EMG signal for the muscle for each individual was similar.
I believe that this project has a broad range of applications and can be used to help various individuals, such as a sign language translating device for the visually impaired, which will help them communicate more effectively. Another real-world application could be used in interactive games or presentations.
This course helped me in understanding how technology can be helpful in the development of medical devices and biological instruments. I would encourage more computer engineering students to take this course.